Okay, hi everyone. I'm Huan from NGI. So today I'm going to share with you some interesting work I did with my colleague, and here are my co-authors. And special thanks to actually Yufei. He was another main contributor to this work. So basically, every work starts with a question, okay, why we did this research. So in one sentence, because we want to develop floating wind turbine, and there are a lot of challenges. And as you can see here, like when it comes to the floating wind, and I think many presenters already mentioned, we are dealing with a large quantity, like hundreds of thousands of anchors. We have much greater geotechnical uncertainty of the seabed. We have very complex load, multi-direction. We have very strict environmental requirement regarding the noise, the disturbance. And we also have very narrow installation window, because that's the money. And we also will have larger footprint for the spacing. So we really need innovation in the anchor solution for the floating wind. So what we can do in terms of that, and there are some solution already regarding, for example, the suction anchor is a very good and successful innovation and has been used successfully for many decades. And so with my colleague, we did some brainstorming, and as you can see, suction anchor can also be used as a tool to install some other anchor, for example, the plate anchor. And what we think is, okay, we can install this ring anchor concept using the suction anchor on top, and with different idea or different requirement, we have actually brainstorming many different configurations to satisfy different need for the, for example, the floater type. And in this presentation, I'm mainly focusing on this. We call it DARA. We name our babies. So it's deeply embedded ring anchor. And so what we thinking is, okay, we reinstall this ring using the suction anchor, then we will do this keying process. It's a bit similar to the plate anchor. And to understand, okay, how this concept really works, we did the FE, large deformation. We also developed this microelement model to really simulate, to understand, okay, if we can capture that behavior. So here is what we get. First, we perform the numerical simulation to understand, okay, how the anchor bearing capacity, how the anchor really behaves. We also develop some simple theory to calculate the anchor capacity. And with that, we also did the FE model to simulate this whole installation and keying process. And we do find, and this ring anchor did offer very high loading efficiency, and it is less embedment loose, so it can be a good solution, actually. So what's next? So in the next step, we are really thinking to do some centrifuge testing or lab testing to really validate our concept. And we are already working with university and some industry partner to really push this forward. So if you are interested, please contact with me. Thank you.